Test, test. So, good evening everybody and very welcome to the Cryosphere Pavilion at COP30 in Belém, Brazil. My name is Fabian Seemann and I'm an early career scientist here from ICCI, the International Cryosphere Climate Initiative. And in this session we are going to talk about the Pakistan's melting glaciers, rising risks for mountain and downstream communities. And I'm happy to have two speakers today, followed by a panel discussion. And the first speaker will be Miriam Jackson. She's the Eurasian and Nordic Director at ICCI, research scientist at the Norwegian Water Resources and Energy Directorate, and a member of the scientific steering group for CLIC, the Climate and Cryosphere World Climate Research Program core project. So I welcome you to the front, Miriam, and hand over the microphone to you. Thank you.
Okay. Thank you very much, Fabian. I hope you can hear me. So it's a delight to be here talking again about glaciers in Pakistan. And I'll also put this in a bit of a global context as well and see how glaciers in the rest of the world are changing also. So I actually finally got to see some glaciers in Pakistan last year. This was part of the Climate-Induced Natural Disasters and Mitigation International Conference. And it was really, sort of sobering to see this in perspective, just how dry parts of Pakistan are, especially Gilgit-Baltistan, which is a bit where I spent most of the time, and how much they're dependent on meltwater from glaciers and from snow melt. And Pakistan's the country with the most glacier ice outside the polar regions. Most of the country, 60-65%, is considered mountainous. So as well as glacier change and changes in snow cover, there's all the other challenges faced with being in a mountainous country and the associated hazards. It's home to the Hindu Kush, Karakoram and Himalaya mountain ranges. And actually you can see where these mountain ranges all meet, which is very exciting if you're a mountain person. And also has 5 of the world's highest peaks over 8,000 meters. This figure is actually from the IPCC report SROC that came out a few years ago. It's a little bit old, but it shows you the mountain areas of the world outside the polar region. What you can see is several mountainous areas of the world outside the polar region, including where we are now, so the tropical region where there's some glaciers, and also showing where we have glaciers and where we have permafrost. The glaciers in blue and the permafrost in purple. I also just want to point out that these are not the same scale. Permafrost or frozen ground is so extensive that if we had the same scale, all you would see is the permafrost. And the glaciers worldwide are changing rapidly. This was a study that just came out a few months ago. It's looking at the glacier changes outside of the ice sheets all over the world. So this now includes the polar glaciers. And what we've seen since 2000 until 2023, there's been huge changes in the glacier mass. And this is using measurements from both in situ monitoring, also from laser scanning, from gravity changes as well. And if you look at the global mass loss, it's about 5%, which is quite a lot, although it doesn't sound really that impressive. However, if you start looking at certain areas of the world, you'll see it's actually much bigger. So Caucasus in the Middle East, it's over 1/3. This is just over 2 decades worth, so you can imagine a few more decades, there's going to be no glaciers left there. In South Asia East, it's over 20%. Remember, there's also hundreds of millions of people who are living downstream from these glaciers, so are dependent on the meltwater from these glaciers. In Western Canada and the US, we're seeing something similar, over 20% of change in the glacier mass. Central Asia, not as much, but Central Asia is very dry. If you were at the conference in Dushanbe, you'll have possibly seen that. And it also means that in the middle of a very hot, dry summer, the glacier melt is really important as well. Low latitudes, so example, Peru, Bolivia, Ecuador, Africa, Indonesia, Also seeing a lot of glacier change, over 20%. These glaciers are quite special because the tropical glaciers, they actually get the precipitation, the snow, all year round, and the melt can happen all year round. There might be some seasons where they get more, but it's not the same as the glaciers that most of us might have worked on, where you get the accumulation in the winter and the ablation in the summer. It can actually happen all year round. So this makes them more sensitive to climate change. And in the southern Andes as well, not quite as much loss, but about 1/8, so quite a lot for a couple of decades. And in case you're wondering what that looks like on the ground, this is, not in Pakistan, this is Yala Glacier in Nepal. And you can see in a few decades it's gone from quite a healthy looking glacier to just a few remnants and basically an oversized ice cube. So looking at the total ice loss between 2000 and 2023 from Greenland, there's also been a lot of ice loss from the Greenland ice sheet. It's an average about 269 gigatons per year over the last couple of decades. From Antarctica, 150 gigatons a year, and obviously these are very big ice sheets. Ultimately, they'll have a huge contribution to global sea level. But what's interesting is the glaciers in the rest of the world, which in total would have a relatively small contribution to global sea level, so less than 1 meter, they're actually having the biggest input to sea level change recently, so 273 gigatons per year. So even though they're very small compared with the ice sheets, it's having a very big effect at the moment. Another thing that's interesting is just how much the mass loss has increased in the past few decades. So looking at Greenland, in the early 90s, it was 105 gigatons a year. It's now between 3 and 4 times bigger. Similar for Antarctica, in the 1980s, it was even smaller, 40 gigatons a year. This was mainly West Antarctica and the Antarctic Peninsula. And now that's really catching up, 252 gigatons a year. And the glaciers in the rest of the world, actually in the most recent decade compared with the previous decade, the ice loss increased 36%. So you can imagine if these kinds of rates of change keep on going, we're going to be losing huge amounts of ice in the next couple of decades. And what does that actually mean? So the mass loss from the Greenland ice sheet, the Antarctic ice sheet, and from all the world's glaciers, as well as thermal expansion of seawater, means that global sea level is rising. And here's an example from Karachi in Pakistan, if you have 1 meter sea level rise. So Karachi is a city of 18 million people, and you can just imagine how many people will be affected already by 1 meter. This is something that will happen in the next century or so, but it could actually happen by the end of this century based on current emissions rates. Calcutta is almost as big, 16 million people, and by the end of this century those people will have a lot less ground to live on. And Dhaka, Bangladesh as well, also looking at big changes. We can also look at 3 meters of sea level rise. This is something, imagine if you had some kind of partial collapse of the West Antarctic ice sheet, increased mass loss from Greenland. So this is something that is probably inevitable in the next few centuries, next 1,000 years or so, but could actually happen by the early 2100s with current emissions. Same for Calcutta, India. I think there was 16 million people, projected population 50 million. By the end of the century. However, I don't think you can get 50 million people in the remaining land. Similarly for Dhaka, I think it's 25 million now, 60 million projected by the end of the decade. Again, that's not much land left for 60 million people. Karachi didn't seem like it was doing too badly, but we look at the area to the southeast of Karachi. I don't know if any of you know it. I must admit I've never been there, but it looks very nice. It's actually a wildlife sanctuary. And even just 1 meter sea level, again, we're probably seeing this by the end of the century, and much of that is going to disappear. 2 meters, and I think most of it's gone, and 3 meters, it's basically history. So this is something that we think is going to happen several centuries from now, but could be 100 years from now based on current emissions. So we can see that coastal communities are very affected by cryosphere loss, even though they might be live a very long way from the cryosphere. Obviously, mountain communities are also affected. They're living in a multi-hazard environment, and actually the number of disaster events is increasing each year. So we have some figures here showing it and showing the increase. the number of disasters, also the number of deaths. So we can't really put a dollar value on that, but obviously causing immense hardship. And also the economic losses are really increasing as well, and these are generally the most vulnerable communities. In regards to the cryosphere, there's several things that are happening as the cryosphere changes. As the glaciers retreat, if the glaciers aren't there anymore, it's quite unstable environment that's left usually. Also, there's often thawing permafrost. The frozen ground is not going to be frozen anymore, so this is going to make it unstable. Snow avalanches are changing. People generally know where the avalanches are. They will avoid them. They won't build houses there. If the avalanches are changing, for example, we're getting more wet snow avalanches which are more destructive, then people could be affected more and more by them. Floods as well. These could be glacial lake outburst floods, could be triggered by intense rain. They could be triggered by permafrost thaw and collapse into the lake, or by a landslide into the lake. And then also there's more infrastructure in mountainous areas, including hydropower, which is also affected by the cryosphere changes. And when we think about risk, we're actually looking at different components of risk. So we have the actual hazard itself, and obviously if you have an avalanche and there's nobody there, it's not really going to have any effect. So it's not just the hazard itself, it's also the exposure. Do you have people living there? Do you have infrastructure there? And also the vulnerability. So the people that live there, if they lose their property, what happens? Do they have insurance? And this shows you the combination that as we get these changes in the cryosphere, a lot of these different components that make up risk are changing and increasing and causing more and more hardship. This is a nice little dashboard that was actually created by ICCI, and it's showing the number of glacial lake outburst floods in high mountain Asia. So this is the Hindu Kush, Himalaya and Central Asia. And you can see we're looking actually at, several hundred glacial lake outburst floods that have been recorded. I also like to point out that not all the GLOFs have been recorded. Imagine like 100 years ago or more, a flood in a very remote community, nobody would really know about it. So we're getting better at recording them, but we're actually probably seeing more and more of them happening as well. Thousands of people have died from these, as well as many injuries and economic losses. And this is just showing you for Pakistan, 146 GLOFs, that's probably a minimum, 146 that have been recorded, and some fatalities and displaced people. This is actually a screenshot I took today, but it sometimes takes a while to update, so I know there were events in Gilgit-Baltistan this year. Sorry, I should also just point out that the URL is at the bottom if you want it. It's very interesting to play around with. A few examples of these events. This is Botokoshi Glacial Lake Outburst. It was actually from a glacial lake in China called Gongwetongshu. It was a very small glacial lake. No one really took any notice of it. And then suddenly this flood happened across the border. So this is another challenge with these kinds of events. They can be transboundary. So this means early warning systems, mitigation in terms of lake lowering is really difficult if the actual hazard is in another country. A fairly local example also, in 1941 there was an ice avalanche that triggered a glacial lake outburst flood. Again, we have this kind of compounding risks where something triggers another event. This flood killed 4,000 people, about a third of the population in Juarez at the time. And in the past few hundred years since the Little Ice Age, there's been 100 or at least 160 GLOFs that we know of. Another event that I'd like to focus on is the GLOF from South Lanark Lake in 2023. Over 100 people dead or missing. Huge amounts, I think 80% of Chirathang was wiped out. 25,000 buildings altogether damaged or destroyed. 30 major bridges lost, a lot of small bridges. Agricultural land damage, a huge hydropower dam destroyed, and other dams that were damaged. And this is a little bit hard to see, but in the middle of the picture near the top is you have the village of Chirathang, or the town of Chirathang, and you can just see the devastation that would happen because of this. What I find really, heartbreaking about this event is that actually scientists knew about it, scientists had studied it, they'd modeled it, they'd looked at the possible volume that you could get from a glacial lake outburst flood, different scenarios, The government in India had started to work on it and they tried some mitigation in the past, lower the lake, but obviously trying to do that kind of thing in high mountain areas is very challenging. They also had started to put in early warning systems, but this is another challenge of these kinds of hazards, that nothing had happened so far. So there's very little urgency there because it hadn't happened so far. So, and scientists can't tell you when it's going to happen. So they started to install an early warning system. Things didn't go quite according to plan, and so they thought, okay, we'll come back and we'll finish it next year. But then it was too late. So the hydropower dam itself was about $490 million. The total cost, billions of dollars. Obviously loss of life that you can't really put a cost on, a value on. A few more events. Chamoli was also in India. Again, this was initially thought to be a gulf, but probably, again, permafrost and thawing mountainside that then collapsed, had a lot of ice in it and caused this hugely devastating debris flood, which again killed over 100 people, a lot of damage. Malamchi as well. Malamchi is in Nepal, and the Malamchi project was actually bringing drinking water to Kathmandu. Kathmandu has several million people. Drinking water was always a challenge, and Malamchi would solve that. And this was a combination of things. So this was intense rain, a gulf, a landslide, and Nepal's very exposed to this because of the earthquake a few years ago in 2015, so it's unstable. And these all came together and caused a huge amount of damage and totally destroyed the water resources for Kathmandu. In Pakistan, this monsoon season has been very damaging. I don't know if we'll get more detail on this later, but there was intense rainfall, several episodes. This also accelerated the snow and glacier melt, a lot of temperature fluctuations, so several floods, landslides and mud flows. In Gilgit-Baltistan there were flash floods, there was also mudslides as well as gulfs, with 31 deaths recorded. And in KP it was mainly disasters due to heavy rainfall and over 500 deaths recorded. This is just 1 year. This is just one summer. Remember, these things are accelerating. So does early warning matter? An example here from Blattern in Switzerland, and some of you may have seen this. This was Blattern, a very pleasant mountain village in the Swiss Alps, and how it looked in May 2025, not quite as pleasant. And what happened in Blattern, there was a mountain beside the glacier, and the mountain, probably because of permafrost thaw, because of the warming climate, there was rock falls onto the glacier. This had been going on for several years. Eventually there was more and more rock falls, it intensified, and when a glacier gains mass, it then tends to advance. Now the mass is usually ice and snow. In this case the increased mass was actually rock, and this increase in mass was so big and so sudden that the glacier collapsed and then caused this huge devastating rock and ice landslide. It also dammed the river, so then there was a lake caused by the dam from the landslide, and you can see the landslide on the left hand side. On the right hand side what you're looking at is actually how much the debris went up the opposite side of the valley. So this gives you some idea of the scale. I've mentioned permafrost a few times. So permafrost is basically frozen ground. It's extensive in the Hindu Kush Himalaya. We don't know much about it. Most of what we know is actually from modeling. We have very few temperature measurements at high elevation. We have some measurements of features that are typical from permafrost, but it's a lot easier to look at permafrost and study it and look at the changes than it is with glaciers. So we do know that it's widespread, we know it's changing, but we don't know much else apart from that. And this is there's a lot of discussion of Arctic permafrost. You see often possibly a lot of buildings collapsing in places like Siberia because of this. Also there's methane that's released when the permafrost thaws. In the Hindu Kush Himalaya it's not quite the same. Possibly on the Tibetan Plateau, QTP, you may get some methane release, but it's still an important problem because people living in this environment are very affected. The infrastructure is exposed, roadways and paths at high elevation. And if the global average temperature was 2 or 3 degrees high, remember this is the track that we're on now, then nearly 60% of the permafrost in HKH would be exposed to thawing. And these are the kinds of surface changes you can see. And sometimes, as mentioned, they can cause collapse into glacial lakes and trigger a flood from the lake. I don't have much time to go into snow, but I'd just like to mention that obviously snow is changing as well. For example, in the Indus, people are a lot more dependent on snow melt than they are from glacier melt. So we often talk about changing glaciers, but the snow cover is changing as well. And people are being affected by that already. People are very dependent on snow melt for agriculture, for hydropower, and this is changing rapidly. A quick plug for our State of the Cryosphere report that we released last week. So this is available from our website. There'll also be a quiz about it. And if you want to know more about glaciers and high mountain areas or the other things to do with the cryosphere like Greenland, Antarctica and sea ice, you can see it there. Thank you very much.
Thank you so much, Miriam, for this wonderful presentation, but also very worrying presentation on the risk of gloves especially. So we can move on to our next presentation, which will be held by Dr. Syed Muhammad Sayab Shah. He is the Senior Director for Risk Assessment at the National Disaster Management Authority in Pakistan, with over 12 years of experience in climate change, disaster risk reduction, impact-based, disaster early warning, and multi-hazard risk analysis across the Global South. He specializes in impact-based forecasting, climate modeling, and vulnerability assessments. Dr. Shah authored Pakistan's first multi-hazard vulnerability and risk assessment policy and led the risk-sensitive spatial planning framework of Pakistan. He led national initiatives such as the National Spatial Data Infrastructure, Cryosphere Preservation Project, and advancing Pakistan's geospatial and catastrophe risk assessment capacity. So, a warm welcome to you, and we're looking forward to your presentation.
Hello everyone. Thanks a lot for providing me this opportunity to reflect on some of my experience, particularly in the domain of the cryosphere. Since I belong from the National Disaster Management Authority, and within NDMA, we have a specific mandate which follows the entire ambit of disaster management. So we have federal lead organization which deals with different disaster management activities. And within the disaster management activities, we have some pre-disaster management interventions, and then some during disasters, and then after the onset of any disaster, so the disaster response initiative. So I will be specifically talking on the DRR subject, and within DRR, I will be talking on the disaster early warning, particularly in the context of the regional cryosphere dynamics of the Hindu Kush, Himalaya and Karakoram region. Okay, I didn't bring along any dedicated presentation for the cryosphere, but since in NEOC, the National Emergency Operations Center, we have a number of different monitoring portals that we keep on developing, and on the basis of those portals, we monitor the different dynamics of the Earth system. I will only be speaking on those important portals which is linked with the cryosphere dynamics. So one of the major important portal within the National Emergency Operations Center is what we call the regional cryosphere dynamics. If you see the Hindu Kush, Himalaya and Karakoram region, which is also known as High Asia Mountain, it is a balloon-shaped, it has a balloon shape, and it stretches along around 2,500 kilometer, and it has a more bulge, towards its eastward side as compared to towards its western side as compared to its eastern side. So principally talking about the overall snow cover in the Hindu Kush, Himalaya and Karakoram region. So around 70% of the overall snow cover, it lies in the east western strip of the HKH region, and around in near the confluence of the Hindu Kush, Himalayan, Karakoram region. So that makes Pakistan a country that has the most glaciers in the world after the polar region, and that is why our country is known as the third pole of the world, or the inverted sea, because of the gigantic volume of the water, fresh water, that this specific region contains. Uh, if we specifically understand the Hindu Kush, Himalayan, Karakoram, and the geographic configuration of Pakistan. So Pakistan is at a very significant position in terms of the geography, because it is at the junction of three major plates, three major mountainous ranges: Hindu Kush, Himalaya, and Karakoram. But in addition to that, we know that it is at a junction of two major plates, with Indian plate subducting beneath the Eurasian plate, and that is why we have around 65% mountains in Pakistan, and there are a wide variety of different mountains in Pakistan. In the northern part, since we are at a confluence of three mountain ranges, so in the northeastern part, we have the Hindu Kush mountain, and then in the most north and northeastern part, it is known as the transverse Himalaya, or the Karakoram range. And then we have a number of different ranges within the Himalaya. It is not only the outer Himalaya or the transverse Himalaya. We do have the inner Himalaya part, and then we have the sub-Himalaya. And then we have a diagonal relation. If you see diagonally, there are a number of different mountain terrains as well. We have diagonally, we have the Suleiman mountain, and then it goes down there in the south, and it becomes a Kirthar mountain. So that is why Pakistan has around 65% of the total mountains. Now, as I said earlier, the northern region of Pakistan, it is a glaciated region, and it is not only the glaciers. We do have the permafrost as well, and some parts we have the ice caps as well, and within the glaciers we have around 13 different kinds of glaciers. It is not only the moraine glaciers or the creek glaciers. We do have the supra glaciers, the surface glaciers. We do have the Piedmont glaciers, and a number of different types of glaciers, and every glacier has its own specific behavior to the entire cryosphere dynamics. But based upon a number of different climate models, we have been developing some long range projection, and this portal basically provides the long range projection of the glacier dynamics under different emission scenarios. We have developed the different emission scenarios. For different emission scenarios, the total glacier change in the northern region of Pakistan, and most of these scenarios, be it the low emission scenario or the high emission scenario, there is a gradual decline in the total snow cover volume and also in the glacier cover volume. The total glacier region, the glaciated cover, spans around more than 16,000 kilometer square, but in the last 10 years we have seen 3% reduction in the total snow cover change in Pakistan, and that has resulted into a number of different cascaded hazards, and I'll be discussing those cascaded hazards in the later part of my presentation. But I would also like to emphasize that in Pakistan we have around 13,000 different glaciers, and that is why it is also known as the third pole. Next. Okay. I will also speak on another another important portal that is developed by the NDMA, that is known as Snow Monitoring Platform. In NUC, we are utilizing a number of different satellite and remote sensing, and also the aerial platform and the ground-based data sensor data sets to understand the total temporal change in the snow cover in the northern, not only in the northern region of Pakistan, but around the High Asia mountains, which include the mountain ranges of the Central Asia. We are monitoring the total snow cover change in the in the other ranges in the Central Asia, For instance, the Pamir range or the Altai range, the Verkhonoyesk of the Russia, and also the transverse Himalaya range and the entire Himalayan ranges. And based on that, we are also developing the total projection of the snow cover for the entire year. That is the and then for the long range projection, we are going till the end of the century as well. Based upon all those emission scenarios, it is certain that our glaciers are retreating. And if we take the SSP5, which is the worst case scenario of fossil fuel rich pathway, this defines that around more than 80% of the total snow cover of the Himalayan range would deplete if we considering the SSP5. Next. Okay, since I discussed earlier that Pakistan lies on a subtropical region, that is, we are diagonally spread from 22 degree of north of latitude and goes up to the 36 degree north of latitude. That makes us a hyperclimatic country because we have a different climatic variations in different regions of Pakistan. If our glacier melts or if there is a change in the snow cover in the northern region, it translates into a number of different cascaded hazards because there are other climatic variations in our plains and in our southern region. As earlier presented by the respected madam, that the seawater level rise would have an effect on the coastal region of Pakistan, but given the higher melting of the glaciers, we are experiencing a number of different cascaded hazards. Particularly, if we talk about the Indus water system of Pakistan, the Indus water system primarily has 5 major tributaries and around more than 36 minor tributaries. We do have the mighty Indus River, and 80% of the flows from the mighty Indus River, it comes from the Gilgit-Baltistan. And if there is a change in the glacier and the snow cover, it will eventually affect the flows into the Indus River and also then to the other tributaries, whether the western tributaries or the eastern tributaries. Based on the last 5 years historical data, we have been witnessing a gradual increase in the water flows in all different river systems of Pakistan. Since 80% of the total net flow that comes to the Indus, it is the glacier melt. Then and within it is the snow and glacier melt, and 20% is fed by the rain effect. And because of that, our major dependency of the total water requirement is met by the volume of the snow and the glaciers that is in the northern region of Pakistan. Based upon the high emission scenarios, and a higher aggravated melting of the glaciers or a lesser snow cover would directly impact the entire water profile of Pakistan. In the first few years, for instance, based on the projections, for the next years till 2045, we would be a water abundant country because of accelerated melting of the glaciers. The flows in the river system would increase. But however, after 2045, the total water volume in the rivers would reduce because of the lesser availability of snow persistence in the northern region, and that water scarcity would translate into a food scarcity as well. Now, another important, I will explain some of the cascaded effects of the cryosphere hazards in Pakistan, and one of that effect is the glacial lake outburst flooding. Since in Pakistan, one of the major anomaly is the temperature anomaly in the northern region. The northern region is subjected to experience more higher temperature, and that higher temperature is actually a cause of our glaciers to melt, and that melting of the glaciers are basically increasing the volume of the glacier, different glacier lakes. Since in Pakistan we have around 36,000 different glacier lakes, and unfortunately these glacier lakes are experiencing a glacial lake outburst flooding. We have identified 36 potential vulnerable glacier lakes, and among them we have developed among them 5 are the most potential glacial lake outburst flooding sites. And what NOC is performing, NUC is continuously developing an entire multi-hazard vulnerability risk analysis of mountainous regions of Pakistan. Okay. So, as I explained earlier, that based upon all these scenarios, around 3% is the total snow cover decline per year. It is a decadal decrease in the snow cover per year. And based upon the projections, all projections, either 2.3 degrees centigrade rise or 4.8 or the other emission scenarios are depicting a gradual decrease in the glaciated volume of Pakistan. So we do have a number of different important monitoring portals such as the snow-covered area. We have developed the climate projections and also the drainage river catchment of the Pakistan. We do have the other important pieces of the cryosphere dynamics that we keep on monitoring and develop their projection. Okay. As indicated earlier, this is the snow cover change till 2050 developed for different emission scenarios. For all emission scenarios, we would experience a gradual decline in the total snow cover volume in Pakistan. This is another important portal that NDMA uses to understand the snow cover change and we relate it with the historical snow cover to do the analysis with the historical snow cover. Okay. Another important portal is the glacier lake outburst flooding analysis. So since I told earlier that in Pakistan we have around 36 major potential sites which can experience glacier lake outburst flooding. So the team NDMA has performed an integrated hazard vulnerability and risk analysis of those potential glacier sites. And if you see this is a flow path that if a specific glacier lake experience an outburst event, so the potential area which would get affected. The red part was the one that is most at risk, while the greener one is the one which is lesser at risk. We have also done an exposure analysis. For instance, if this flood pattern is developed, so how many population would get affected, how many critical infrastructure, bridges, road, network, agriculture, and around 36 different exposure elements. We calculate them, and based upon that calculation, we have set some particular triggers for temperature, for the snow cover volume, and a number of around 17 different triggers we do have. And on the if a specific trigger is crossed, so then we initiate our early action and early warning that these regions have to respond to a specific threat that is likely to happen in that region. So specifically talking about the HKH region, so mass balance is overall negative. Our snow line is moving northward, and our forest cover is increasing in the north. That is a direct, it has a direct relation. If your snow line moves upward, so your forest cover moves upward as well. We do have many glaciers are shrinking, but if you see the Karakoram, okay. This is another important portal with NDMA, wherein we keep on monitoring the land surface temperature and also the different dynamics of the weather pattern to develop the early warning with regard to different hydrometeorological hazards. For instance, I will just speak few words on the temperature rise in the snow cover. In 2025, during the month of June, our team developed the seasonal forecast, and we earlier predicted that this year the northern region of Pakistan, and not only the northern region of Pakistan, but also the Himachal Pradesh, Uttarakhand, and the Tibetan plateau, this region overall would experience higher temperature anomalies. Higher temperature anomalies in the Tibetan plateau or in the northern regions of Pakistan directly means more melting of the glacier and more flows into the river streams. In addition to that, our team also predicted that in the month of January and February of 2025, we predicted that we would have less snow cover. Normally there is an inverse relationship between the total snow cover with the monsoon, monsoon intensity. There is an inverse relationship. When in the winter, if you have a lesser snow cover, in the summer you have a more aggressive rainfall. And a higher land surface temperature in the northern region of Pakistan also create a low pressure that attracts the monsoon currents to create more massive rainfall during the peak summer season. This actually happened and unfolded during the monsoon 2025. We already predicted because we were expecting lesser snow cover in the 2025 winter and more temperature anomalies in the summer of 2025. And because of that, our team developed a complete disaster early warning that the year 2025 would be the year of different variants of floods. We already expected that the northeastern region of Pakistan would experience higher rainfall and more melting of the glaciers in the upstream areas of Pakistan. In addition to that, it was also determined that there would be an episodic western disturbance confluence with the monsoon current that could create cloudburst event, the flash flood events, and that happened actually in the Khyber Pakhtunkhwa province of Pakistan. We experienced a flash flood in one of the city of Pakistan, and also in Gilgit-Baltistan there were a number of different landslides events, the debris flow, the mud flow, and also the glacier lake outburst flooding. We experienced 2 glacier lake outburst flooding because of the anomalous behavior of the western disturbance and also the aggravated temperature anomalies in the northern region of Pakistan. This is what I explained. Okay. We were also in the year 2025 we kept on monitoring the behavior of the Tibetan plateau, because Tibetan plateau normally, if you have a more land surface temperature at the Tibetan, it creates a low pressure, and low pressure system, it creates a low pressure, and that low pressure attracts the sea breeze to reach to the northern to the maximum fringes of Pakistan. Because of continuous increase in the Tibetan plateau temperature, we have seen that the monsoon has moved 100-kilometer grid westward and is now affecting those regions of Pakistan that earlier were not within the range of the monsoon. So based upon number of different climate models, we are expecting that every year the monsoon would become more aggressive, and even for the year 2026, the long range climate models are indicating 22% more rain anomalies during the month of July, August and September, particularly for the northeastern part of Punjab. And we are also expecting higher land surface temperature, and the land surface temperature in the northern glaciated region of Pakistan are 4 times more higher as compared to the other parts of the Pakistan. Okay, but there is an exciting, effect that not all glaciers are retreating. In Pakistan, there is another phenomena, particularly in the Karakoram, what we call the Karakoram anomaly. In the Karakoram anomaly is that although most of the glaciers are either exhibiting a glacier mass balance, or some glaciers have the snow line moving southward, which indicates that these glaciers are still, advancing because of the higher snow cover only limited to the northern strips of the Karakoram. The reason is that the Karakoram range is the most elevated range, and it ranges from 6,000 meter and beyond to the 8,000 meter. This much height normally creates an orographic, effect. And because of the aggressive western disturbance, we have been observing that the western disturbance that brings the rain from the Mediterranean, Black and Caspian Sea is becoming high, and that higher western disturbance is creating more snowfall in the only Karakoram range. So Karakoram is exhibiting a glacial mass balance, but the other ranges, Hindu Kush and the Himalaya and all different ranges of Himalaya, either the Pir Panjal range, Dolodar range, Shivalik range, and the number of other range, they are showing lesser snow cover persistence, but the Karakoram range is exhibiting a high snow persistence compared with the other parts of the mountainous regions of Pakistan. This is one of the initiative undertaken by the National Disaster Management Authority, which we call the Regional Glacier Preservation Strategy. Okay. Turn off the volume, please. Okay. This one is one scenario that we have developed for the monsoon 2025. It is a scenario which actually happened. So it is just a visual depiction of monsoon 2025, wherein okay, am I audible now? This is a visual depiction of the monsoon 2025 related mountainous hazards. A visual depiction wherein a 200 millimeter rainfall occurred in one of the valley of Pakistan, Swat, and this is a visual depiction. Next. Okay, this is also a visual depiction of another glacial lake outburst flooding event that happened in one of the valley of the northern region of Pakistan, a glacial lake outburst flooding. So a complete animation is developed using the remote sensing based analysis data sets. So this is another one of the, this is the GLOF event, happened in Chitral. In this year. Okay, these are some methodology. I won't go into details. So that's it. Thank you.
Thank you very much, Dr. Shah. Yeah, thank you very much for this very impressive presentation on risk management in Pakistan. And instead of doing individual questions, I would like to welcome you as well as Miriam Jackson to the stage so we can have a small Q&A. But also I would like to welcome Zara Malik to the stage to join us for this little Q&A session. Zara Malik is a civil servant of Pakistan at the National Disaster Management Authority. So, yes. So I actually would like to start with you, Sarah, because you are working actually with the communities. And for me, the question would be, how do you provide the early warnings to the communities effectively? What different ways of communications are there? Are these all reliant on electricity, for example, would be also interesting for me, because I could imagine that during such disasters there are blackouts. So maybe you can give us an overview of the warning systems that you have.
Thank you so much for having me here. Pertaining to our first question, how we proceed with our risk communication at Pakistan. So we have a holistic risk communication strategy which is integrated by multi-channel implementation of with specific to the hazards and reaching out the risk communication and the risk hazard awareness and messages to each mile. So how we can do that? We first of all we have a traditional method to go with, which includes the deployment of the alerts and emergency information to the through the satellite TV channels, through the print media, including the social media, digital media platforms are also being utilized immensely. So simultaneously we also incorporate the United Disaster Media Support Group in Pakistan, supported by the National Emergencies Operations Center. When we receive a disaster early warning from our tech team, we disseminate it to the each people and each communities at the risk through all the medium and the channels. So that United Disaster Media Support Group is very pivotal and crucial for the dissemination of alerts and emergency information to the communities at risk at state specific messaging. Secondly, we also incorporated the vast framework of community radio channels. When we can't go with the satellite TV channels, internet is slowed down, there is infrastructure problems with the telecommunication, so we go with the AM and FM's radio TV channels to reach out to the communities. Along with that, we also have the very comprehensive and widespread network of mosques and churches. So whenever there is a high alert in particular area, we pass on our information to the mosque, the religious leader and the community center head, and then they come up on the siren or their speaker and inform the communities to evacuate and do the protocol and safety and implement the safety protocols and guidelines. So this is how we relay our risk communication at NDMA and in Pakistan, specifically to the mountainous people who are sparse and very culturally diverse. So for them, we also create the number of content to aware the people for their hazards and give them the guidance and prevention guidelines to how to prevent them and get more prepared from the impending disasters and hazards. So this is the risk communication, how we're doing in NDM.
Great, thank you very much also for these very nice animations and videos in the background on effective risk management in these communities. Dr. Shah, so right now we have been looking at the communities located in the mountain regions. I would like now to turn the other way around and look downstream. So what are the cascading effects of glacier melt and snow cover change in the downstream communities? How far are such events as gloves reaching downstream? Can you give us like some examples on is it like a couple of kilometers the effects, or can it be hundreds of kilometers the effects reaching downslope? And how many people are potentially affected in the downstream communities?
Since I discussed about the mountain hazards, and there are different variants of mountain hazards, and the impact depends upon which type of hazard are we discussing. One of the most imminent hazard is the glacial lake outburst flooding, and when a glacial lake outburst flooding happens, obviously a gushing water goes to the downstream areas, and obviously there are number of different settlements in the downstream areas. So for instance, in Pakistan, specifically in the context of Pakistan, wherein we have 36,000 glacial lakes, and among them around 50 glacier lakes are potentially vulnerable, and we have been experiencing the frequent flooding in 5 most vulnerable glacier lakes. And one of that glacier lake is the name is very familiar, the Shishpur Glacier. Madam has also written in one of his slides of presentation about the Shishpur Glacier. So downstream in the Shishpur Glacier, we have around 300 total settlements, and within each settlement there are around 200 homes. And in Pakistan, as per the Pakistan Bureau of Statistics, roughly speaking, one home has 6 people. So just multiply 6 multiplied by 200, which makes one settlement, multiply by 300, which makes one settlement, and we have 300 settlements, so then multiply by 300. So this is a huge number. So obviously in the downstream there are a lot of people, but it's not only the people. We do have many critical infrastructures such as the road networks, the bridges, and there are a number of different important bridges which are the main nerve to connect those mountainous communities with the rest of the country. And normally when such event happens, it also impact the bridges, the essential infrastructure in the form of let's say the water supply mechanism, the agriculture fields and number of other. So the impact is gigantic. But the mountainous hazards are not only limited to the mountains, because for instance, aggravated melting of the glacier would also increase the flows in the river. And when there is a increased flow in the river, it will also cause river swelling. And in Pakistan, the river flows from north till south, and it spans for more than around 1400 kilometer. So the whole area, 1400 kilometer, in the fringes of the river, those people who are living and residing there, we call it the floodplains. And in Pakistan, there are a number of settlements that are within the floodplains. And when during the peak flood season, when there is a swelling of the river, and the floodplain normally gets inundated. So all those people, those communities that are residing within those floodplains get impacted. We do have a massive agriculture area in Pakistan. Around 45% of the total area of Pakistan is agrariable, and this is the major, we call the Punjab province and Sindh the food basket of the world, because we have a lot of agriculture potential over there. But unfortunately, most of these agriculture potential comes in the riparian area, where normally in the peak monsoon we experience a flood, and that also affect the agriculture land of Pakistan. And around more than 45% of the people of Pakistan are associated with the agriculture. So it affects their livelihood. It affects the entire economy of Pakistan. So whatever happens in the north, a ripple effect comes to every part and segment of the other part of Pakistan. Thank you.
Thank you very much. So I would like to have a last question for Miriam for the session. So we have seen the extensiveness of risks associated with glacier melt in the Himalayan region. Now with specific examples from Pakistan, you also gave us an overview about international risks, and you've also mentioned the problem of along border lines risks. So I was wondering, can you tell us something about international networks on risk management, if there are any, or any cooperations between countries on risk management, such as on GLOFs? Maybe you can give us a short overview from the Himalayan region or elsewhere.
Thank you for the question, Fabian, and this is a very important question about international cooperation, especially concerning transboundary hazards. And there are a few existing institutions already in place. For example, we have the World Meteorological Organization, who is trying to make sure that observations are systematic, that they're uniform between different countries, organize several meetings, for people to discuss the various challenges they face. They do also have some meetings specifically about high mountain observations and high mountain areas. Another facility they have is SOF, which is, I can't remember now, the Systematic Observation Financing Facility, I think. And this is specifically aimed at low-income developing countries to try and to give them the extra boost they need, because it's often these developing countries that have the most challenges concerning meteorological and climatological related challenges. So that's in place already. I know they're very active in Bhutan. I think also Pakistan's involved, but I'm not sure. We also have other organizations such as ICCI, which is where I worked previously, and also how I know a little bit about cryosphere change in the Hindu Kush Himalaya. So ICCI is working in 8 countries in the region. This is including Pakistan, India, Nepal, China, Myanmar, Bangladesh, a few others. And these countries all border each other. And so one of the things that ICCI is to organize, for example, workshops where you bring together perhaps students from the different countries, or you bring together professionals from the different countries. I've certainly been at a workshop before where there was professionals from the meteorological organizations. They might also have things like a ministerial dialogue, where you actually get the ministers from the different countries in the room. And imagine this is sometimes a politically challenging area, So ICCI is able to provide a neutral arena for people to come together and discuss the various challenges. And this can then obviously include things like data sharing and how to perhaps perform mitigation when you have a hazard on one side of a border and the country affected is on the other side. So there's already a lot of cooperation in the region through these international organizations. Several other of the UN organizations, UNEP, UNDP, for example, are very active in the regions, and they tend to have country focal points, but also have regional focal points as well. So there are a lot of mechanisms in place. I think it's, the people involved in them recognize the importance. Perhaps outsiders don't always recognize the importance, but there's a lot of willingness to share data and to look at common problems from a common angle and solve them together. So I think we really have to, encourage these organizations that it can be a challenging area to work for all kinds of different reasons, especially because of transboundary problems, but there are mechanisms already in place to try and address these challenges.
Great, thank you very much. So we're coming to the end of our session this evening, as we have one more event upcoming tonight at this pavilion. So I would like to thank you very much for your presence. And okay, we will have one short question from the audience before we then move on to the next event.
Okay, can you make video? Okay, that's not the question actually. I would like to add the next step into that, what we do in NDMA. Like we have the early warning, like the Dr. Tayyib is explaining on that, and we have the risk communication as well, and we have the international collaboration. So what we do at NDMA, we also have a mechanism to collaborate with the local driven national NGOs. We have a collaboration with the international non-governmental organizations and with the UN. So what we do, we collaborate with all humanitarian partners and to plan some capacity building initiatives in the vulnerable areas. Like we do simulation exercises after the issuance of the disaster early warning, after the issuance of the risk that already held in the in the vulnerable areas. So we do capacity building initiatives, we do simulation exercises to warn the people so that they can be prepared well in time. So this is what I would like to add. Thank you.
Yeah, great. Thank you for this very important input also. So yes, one more time, thank you very much for being here tonight at our pavilion, and yes, I wish you all a good evening. Thank you.